need perfected notes, but we do need some notes to be taken during the meeting for us to be able to proceed. Okay, thank you, Dave. Dave Dawson, thank you. Are you able to take them in Etherpad? Yes. Excellent, thank you. We're also looking for somebody to keep an eye on Jabber for us, just in case we forget. Excellent, thank you very much. Can you announce yourself in the Jabber room?
Put your name on that.
My name, yeah.
Okay. Escape out of there. Browser. We ought to have the agenda up in the window. That's probably a good idea. Or you're uploading
I've got an agenda.
Oh, okay. Should we switch over to yours or?
No, sorry. Yeah, can you show the agenda? Because mine was being hacked to show who's doing what.
Okay, I'll take.
It's really good, this secret mic, isn't it?
You know exactly what we're doing. It's not like this is a private meeting.
No, it's okay. Right. We have 1 minute to go.
I should do it. Hang on a minute. Screen went blank on me. That's interesting. Just a minute.
It's cool.
All right.
You ready?
Hang on. Not sure. Just a minute here. Okay. Wait a minute. There's something peculiar going on with displays. That's what the problem is. Bingo. I should do it. Okay. Sorry, I'm simple. I can't deal with two displays that don't do the same thing.
Oh. So, welcome everybody. This is the Transport Area Working Group again, and we are about to start. Have you? There we go. I'm Gori Fairhurst. I'm one of the co-chairs here. We have a second co-chair, Wazedi, who's not able to make this meeting. He's traveling somewhere else and unable to join us today. But David Black, my other co-chair, is sitting beside me, and he's going to introduce the meeting today.
Okay, so welcome to the first of two TSVWG sessions in Prague. This is the Note Well. I think there's an RFC number 2 has been updated. In any case, it applies to you. So we've identified note takers and Jabber scribes. Jabber scribes, thank you all very much. We, as always, will need reviewers for working group drafts. We'll ask as we go through the session people to take a look at things. And a reminder, please use TSVWG with dash before and after as part of the name of internet draft submitted if you want us to notice it. We'll say that's what we look for in trying to figure out what's relevant to the meeting. Standing document review request. Document quality relies on reviews. Please review documents in your working group and at least one of the documents for another working group. In general, if you'd like documents you care about reviewed, please put in the effort to review other documents. Okay. Acknowledgements and status. We got 4 RFCs published between IETF 97-98 between Seoul and Chicago. So we've had no RFCs published since then. They seem to come in waves. We're working on creating the next one. There are 2 net drafts in the RFC editor queue, DivServ and WebRTC QoS, and the details in cap of SCTP. Both of these are in misref state for the SCTP end data draft, about which we have good news to report. There are no IDs in IETF. There are no net drafts in IETF last call, post IETF last call processing, but we hope to see that change soon. So the end data draft, which are 2 drafts that the RFC editor are waiting for, is now in AD evaluation before IETF last call, as is ECN experimentation. And in just a little bit, we'll talk about some minor changes coming to ECN experimentation. There's been some discussion about what we're going to do about IANA consideration of that draft. Challenge ingestion feedback. We have an open issue with that draft. We were last call. We've talked to the area directors. We'll need to go talk to the authors. We think, unfortunately, that significant changes to that draft are going to be required to resolve that open issue. Are any of the challenge ingestion feedback draft authors here today? We'll take it up with them offline, but some significant changes are going to be required to that draft. Spencer.
Yeah, Spencer Dawkins, responsible area director. I did a chunk draft. I'm about halfway through AD evaluation on, and I really like it. I am generating a decent number of comments, but most of them are questions about clarity. The ECN experimentation one, have we closed on what that one really needs to say?
Yes. Why don't we do that now? What ECN experimentation is going to do, part of what ECN experimentation draft does is it documents the end of the ECN nonce experiment and provides the rationale for making the ECN nonce RFC, which I think is 3540, historic. We're going to add one line to that removes the registration of the flag in the TCP header that was used by the ECN nonce. Accurate ECN needs that flag. The TCPM working group will figure out how to use that flag for accurate ECN. But in this draft, we're just simply going to remove the registration.
Cool, thank you. I had been waiting on that one to settle down before I finished an AD evaluation of it. So
right. So
but I'm trying to keep up. You guys are doing a lot of work.
Oh, just wait till you get to some of these slides. There's more stuff here.
David, can I ask you on this one when you're going to submit the update? Is that ready to do in the next week or 2?
That update will come in next week or 2. The update will do 2 things. One is it will change the considerations, and the other is it will add the ECN++ name for the generalized ECN work over in TCPM. That probably will not be this week. I'm going to guess next week.
So I just found out yesterday that the end data draft was on the 3GPP dependency thing, which I did not know. Sitting in the meeting where they were reviewing the dependencies, so properly motivated. I'll probably do it tonight.
It's the last of our RTC web dependency drafts. We're so glad to be freed from that hairball.
Hi, Bob. Just to point out, there'll be another dependency in that you'll need to write some, or one of the ADs will need to write some status change thing.
That's correct. In order to send ECN experimentation, Spencer.
Just do it for this draft.
Spencer.
I just said.
Bob is reminding you have another action item on your to-do list, which is in order to send ECN experimentation to IETF last call, you need to send a 3540 status change document to last call at the same time with it. And you get to write that one.
Absolutely. Cool. Thank you very much.
Occasionally we can give the ADs work on it. It usually runs the other way.
So it turns out that public humiliation is really motivating for ADs, and this worked. Just remember that.
It works both ways. Okay. We have one ID that's basically completing second working group last call. We're going to declare the end of that working group last call on the DIF-served IEEE 802.11 Wi-Fi mapping draft this week. Let's see. We're going to do that today, and Tim's got a few slides on what he's going to do about it. The good news is the mappings, the code point mappings are stable. All the changes and all the discussion is around traffic conditioning text and what to do with certain classes of traffic, but not the base mappings. We are hoping to get through the serious open issue on the diff-serve lower effort PHB draft today, which is which DSCP to use. Once we get through that one, it should be ready to go to working group last call. And we've got 8 more working group drafts, all of which will get covered today and Thursday. A couple, 1 and 2 are easy encapsulation. 3 and 4 are more SCTP support. 5, 6, and 7 are L4S. 8 is UDP options draft. But wait, there's more. As noted in the mailing list, we are announcing the working group adoption of these 2 FEC, forward error correction drafts. Vincent Roca has been working on these. I have not had time to update these slides. The agenda is updated. These are now working group drafts. I will probably, in my copious spare time, produce a V3 of these slides that gets these draft names updated to the correct draft names for the working group drafts. Reason for doing this is TSVWG is, among other things, the home of maintenance work on transport area protocols that doesn't justify forming its own working group. This is a moderate-sized update to FEC, and we don't expect any additional FEC work, and that's why it's here. Okay, some related drafts. My long-suffering and hard-working co-chair has written a couple of drafts on transport header encryption impacts and datagram packetization path MTU detection. You want to say anything about those, Gory?
Talk to me about them if you're interested. Mm-hmm. They're initial versions, so just talk to me if you're interested.
Right. So, offline discussions here, you may see them come back. There are 3 drafts related to TSVWG that are over on the int area agenda this time around. The int area tunnels draft, which we've talked about here a number of times before. MTU is a particularly important topic in that draft, and it does a good job on that. A draft on a network multipathing was initially targeted TSVWG. It sure looks like it's a more appropriate draft for int area because it's mostly about how to send packets down network paths in parallel. And there's a version 6 draft of the a draft for version 6 of the SOX protocol, again also being actively discussed in int area and on their agenda. If you're interested in any of these 3, please go to the int area meeting, which I think is on Thursday before our second session.
Maybe I can add on the final one, or any of these. If you think there are specific transport issues, then please speak up on the mailing list or tell us. If they happen to be more related to some other area in the IETF, we will do the main work there.
Mm-hmm. Okay, so we need to go. I need to go switch over in a minute to bash the agenda. We've mostly done Dr. accomplishments and status. Milestone review is next, and then there's drafts. Thursday's agenda, you'll see the note well again and drafts. So let me go see about getting the agenda up on the screen. Okay, so this agenda's been bashed a few times. I was editing it just before the meeting. So we need to do status updates. We're going to quick cover 2.1 through 2.3 once we get done with the agenda bash, and then Tim's got a few words to say about the 802.11 diff-serve draft. We've noted these drafts as being of related interest. Then the bulk of today's meeting is DiffServ, ECN, and L4S drafts. The ECN drafts are actually ECN encapsulation drafts. And then on Thursday, we're going to take a look at a couple of SCTP drafts. RC4960 is the main SCTP spec, the two FEC frame drafts, and a individual draft from Michael Tuxon on some considerations and updates to UDP and CAP of SCTP. Any comments, questions, requests? All right, consider the agenda bashed. Let's quick knock off items 2.1 through 2.3. We've basically done 2.1. I think we've basically gone through 2.1, 2.2, and 2.3. The tongue congestion draft, tongue congestion feedback draft. The outcome is that it's going to need some significant more work. In particular, I think we want to see a worked example in it, and we'll take this up directly with draft authors. ECN experimentation, you just heard the colloquy between myself and the area director. That draft's going to get an update on, then he'll take it from there. And the end data draft is in the AD's hands. And with that, Tim, let me see if I can get your slides up here. You want to talk about the 802.11 draft?
Yeah, or you can just share. Probably just right. You can point. You can pick box.
Full screen mode. There we go.
Stand in the pink box, please.
Yeah. So you have to tell me to advance slides. I don't have the remote hooked up, but that's a pointer.
Sure. Okay.
Sorry.
So Tim Seghetti, Cisco Systems. I'd just like to review where we are with the DiffServ to 802.11 mapping. The mappings, the reasons behind this, of course, we have so much more traffic now that's wireless. In fact, the balance has shifted. There is now more IP traffic that is sourced from wireless devices than wired. That happened this year. That trend is going to continue. By 2021, it's expected that 63% of traffic will be sourced from wireless devices. However, QoS policies are not aligned because we have two independent autonomous standards bodies administering this. Not administering, but administering the standards, pardon me. And then the goal is to maintain that consistency of treatment, regardless of whether the traffic is on a wired or wireless network. The next slide, please. As David mentioned, the mappings themselves have been stabilized. We've had 2 years of discussions, really good discussions on the group. And so this is now good to go. The couple areas that we are going to talk about have to do with the scavenger class or the LE PHP that Roland will be discussing. I'll return to that in a moment. But then if we could just take a look at the next slide. I want to make the point too is that these are already in wide use on millions of devices. From Cisco, we wanted to get, well, this whole initiative started by getting our own house in order. And then we realized, look, why do we have so much disparity from one platform, one software version to another? And then we wanted to do a greater service to the internet community at large by arriving at a consensus recommendation so that we'd have that consistency across all vendors, across not only the makers of APs and wireless infrastructure, but also wireless endpoint devices. So I think I tallied this up. It's like about 800 million devices are already using the recommendations put forward in this proposed standard. What's remaining, if you may? Some comments from David coming from a security background. Even though in the terminology in section 1.6 of this document, we outlined the context of the word trust and untrusted. These are used extensively in RFC 4594, which is what we draw heavily from. However, we do recognize very clearly that these have very strong definitions outside of QoS. So to avoid that confusion, we will make the changes to the wording and avoid the use of the wording trust. We will use other things like pass-through and process and other suggestions that have been made by David, and very happy to do that. I'm much more intent on pushing this through than getting tripped up on wording. The next point, we do have a dependency. We have a dependency on 4594. The goal of this draft wasn't to introduce new recommendations as much as to reconcile existing recommendations. So as the LE PHP draft will solidify and hopefully That will be soon, Roland's draft there. That will have a direct impact on obsoleting RFC 3662, the marking for this lower per domain behavior, which will now be a per hop behavior. And then that in turn has a cascading effect on 4594. In turn, that will have an effect on ours. We're very happy to make those changes once they are finalized, and we'll do that. And then finally, just some wording nits have been suggested, and I'm welcoming any more during this working group last call number 2. What we're asking for, the final slide, is that we will make all the changes per your comments, per your reviews. I want to say thank you for everyone that has done a review on this so far. It's very valuable, I think, to the industry at large, and so we really appreciate you taking the time and offering that feedback. And then we'll make that reviews soon as within a few days of the working group last call closing, and then we'll ask the chairs for a shepherding report and passing it down to or passing it up to IESG.
All right.
I like the down.
Yeah,
like
I believe so. I believe the working group last call is now closed. But of course, if somebody has any last minute comments, get them in. We would like the chairs share Tim's sense of urgency. We'd like to move this draft sooner rather than later. And so what we're going to do on the issue around LE is let's see where that DSCP discussion that we're about to have goes. And if we have a pretty clear consensus and we know where we're going, we can update this draft to encompass the LE draft. If, however, it looks like we have a long adventure ahead of us, we're going to figure out how to ship this one and deal with the new improved LE later.
That's fair.
Okay, thank you.
Okay,
thank you, Tim.
very much.
Does anybody have any comments in the working group last call that they want to bring to the mic? Well, use the mic, use the mailing list, speak to this gentleman. He's quite happy at the moment. We got lots of comments during the process of developing this draft. We don't expect more, but we'd really, really like to hear them this week if there are any.
Okay.
Thank you, Tim.
Thank you.
Thank you. All right. Do we have anything to say about UDP options aside from the fact that we've adopted this draft? All right. We have someone who's going to say something about it. Cool.
Hello. Tom Jones, University of Aberdeen. We have a working implementation on top of FreeBSD. We would love to speak to anyone who's interested in running our code or anybody who's interested in doing an implementation on another operating system so we could do some interoperability. Probably best if you want to talk to us, you track me down.
Mm-hmm. And running code is kind of important for this draft because it's taking advantage of otherwise unused space that turns up if the IP packet length and UDP packet length don't match. And so interaction with existing implementations that aren't expecting this is of major interest. Okay.
Comment?
Just a second. When you changed the FreeBSD code, it's Dave Dolson, Sandvine. Did you notice if the old code would have been okay with the options? It sounds like you made FreeBSD support the UDP options. Was the old code a problem? So would an old FreeBSD version trip over the options in an incoming packet?
So if you look back as far as the 4.3 BSD stack, this space is trimmed out of the packet anyway, so it shouldn't cause any issues with running hosts. So we think it should be okay everywhere.
Thinks good. People who wish to experiment, please speak to Tom. Okay, working group drafts.
Working group drafts. LEPHB is first. Should we start with Roland's slides, or do you want to start with the measurement slides?
Roland?
Well, why don't we start with your slides, Roland, to set context. So we just bashed the agenda. We're going to do 3.2 before 3.1.
Or you can come back at the end and talk more. It's all up to you, Roland.
Oh, okay. Yeah, so this is a quick update on version 0.2. So I applied several suggestions from David. Thanks for the thorough review. So yeah, the changes are also documented right now in the draft. So I clarified something that has to do with deployment. The IANA section was a little bit cleaned up, and I also added multicast traffic as a potential use case. So multicast traffic usually has a problem that multicast traffic can suddenly appear in your domain as soon as a branch is newly created. And in that case, if you want to avoid, let's say, traffic sources that can cause severe congestion in your ISP network, you may be better off using LE in order to avoid that. So that could actually help in deploying a little bit multicast and on a more global scale. I also added text about implementations using AQMs and ECN usage for LE, and I also revised text in the security section. So next slide. Yeah, so one aspect that came a little bit more clear in this version is that one essential characteristic of LE is that it has this no harm to best effort traffic property. And so if a provider actually decides not to support lower effort, then it cannot take advantage of this feature. So they must be aware that there may be side effects on best effort traffic if they carry lower effort within the best effort aggregate. And currently the draft discusses two types of users. One is the LE min user, which means the user doesn't care whether lower effort traffic is actually better treated than the intended. So remarking to best effort is okay for them. And the other user is the LE strict user, which means he doesn't want to he doesn't want that the LE traffic is treated better than or nearly as good as best effort. So he wants to make sure that LE is only transmitted if the resources are otherwise unused, and wants to make sure that this no harm property is actually guaranteed. So in that respect, maybe the difference would be if we would use two different code points for that. The LE strict code point would be remarked to BE in case it's carried as best effort, so that it can be detected by the endpoints, for example. So currently the draft proposes only to use the LE min semantics, and maybe to use some kind of lower effort transport like LATBAT if you want to make sure that your traffic is really pushed in the background. So one question is, have we means to detect any LE remarking using, I don't know, the connection establishment for TCP or something? So we usually need then some kind of DSCP feedback. There's right now, at least to my knowledge, no means for doing that. Next slide. So next steps. I'm not sure whether people like the semantics of LE min, LE strict. I don't know. I mean, for me, LE min is fine, but it seems that people made some comments in the past that they have LE strict semantics in mind. And I don't think that we need actually two DSCPs to support this. So yeah, one DSCP is maybe enough, but this is time to discuss now. And if we have one DSCP, right now the draft suggests to use DSCP number 2, which is the main purpose of the draft, right? So it removes the ambiguity that was introduced in 3662 and also the follow-on draft. So the idea is the DSCP should not be bleached in case the upper bits are cleared due to IP precedence clearance. So there's only a small set of potential choices left in the current DSCP standard pool. And yeah, so I guess Gori has more input data just in a few minutes. And so, yeah, more reviews and feedback appreciated. And yeah, I think we are nearly ready for going to working group last call, except the fact that we may have to think about updating the 802.11 mapping draft or the WebRTC draft after they've been published. I don't know.
Let's come back to that after we've done the next talk.
Yeah, let's figure out what we're going to do with the DSCP and how fast we can converge on it.
So, Tom, does your question relate to this talk or to the selection of the code point?
The selection of the code point.
Okay, let's take a talk on that first.
Okay.
Right.
More questions?
Are there any other questions for Roland on the draft as it is?
Why not?
Okay, well, come back in a moment.
Alrighty.
Enter the pink box.
Okay, so I'm here to present a set of measurement on DSCP. This is the follow-up of a talk that we had in MapRG, where we present some of this measurement in the last IETF. And now we have done a bit more experiments, and we want to present that. Next. So really this talk is about what would be the best choice for a code point for LE. What's the state of this discussion? First of all, RSC 4594 specified CS1, but is understood that this is not a good choice. It would be 001000, and by the way, now the IANA register report, to simplify this discussion, also the binary of this code point. So that there is consensus that's not a good choice because we will create a priority inversion. So we should select something that starts with 000 and then something in the top down and the bottom 3 bits. And the current, as we've seen, the current suggestion is 010. So our experiments, our measurement were meant to really see if it will work in today's network. And it's a good starting point because we saw that at least it has a good survivability in the internet, in the sense that using this code point, it in a large number of paths, it's if we color the packet with this DSCP, can get to the other end. Next slide. So first, let me spend a couple of words about what experiment we did. We developed this tool called PathScope, which has the same is inspired by traceroute. It has a traffic generator that uses SYN packet to send SYN packet to a target and increase the time to live each time. Then it collects all the ICMP that because of the time to live expiration at the traffic at the sender, and it does an analysis of what it sees, starting with different code points. So it changed the code point, is scriptable, so you can decide which code point to start with, and it does this automatically. And we've done this with several code points from 3 vantage points in this open network called Digital Ocean, from 3 vantage points towards 300 targets chosen randomly from the Alexa 1 million list using TCP and UDP. And next slide. So one pathology that we saw starting with several code points is that the top 3 bits are sometimes bleached. We call this toss bleaching because these 3 bits correspond to the whole TOS semantic. And this means that, for example, what you've seen, that several compile like AF11, AF21, AF31, and AF41, that all have this 3-bit non-zero, but the bottom 3-bit are 0, 1, 0. After resetting, are mapped to DSCP2. Similarly, for AF12, F22, 32, and 42, we have the top 3-bit non-zero and are mapped, but the bottom 3-bit 1, 0, 0, and are mapped to DSCP4. And the same story for AF13, F23. So how often do we see this? That's the question. With all these 900 unique source destination pay, we see that 70% of paths have DSCP modified. So the SCP at the end of the path wasn't the same as the one that we set at to start with. But in 10%, we had this pathology TOS bleach. So you understand what is the threat here is that some, if, for example, if you choose DSCP2 and if we start with a high priority class like AF11, it will be mapped to DSCP2. Next. So then we've done some other of this measurement. We develop another tool called Edge Trace that is called Edge Trace because it wants to do exactly the opposite of this. So it's starting from a pool of sources at the edge of the network, and we had control of 177 nodes distributed across the network. There are more on this was on the MapRG presentation. Using this tool, we can see also looking at this web page here at the bottom, we saw that when we send a probe from one of these points to one central server, we saw that this pathology of TOS bleaching was non-insignificant. We had this 17%. And also we had the other measurement using a mobile network in a project called Monroe, where really this network is use mobile nodes in different operator across wireless operator across Europe, where we have both control of the sender and the receiver. You could instantiate a experiment using two nodes, and we have the opportunity to probe many tests, many paths across this network. And here we saw various other pathology, but still the TOS bleaching was detectable because we had at least 4.7 when we went to see the pathology specific of a certain router. So how did the SCP change from the input to the output? In 4.7% of the routers presented this pathology. Next. So okay, that sets up the question is what is the SCP2 the best choice, because we can see this issue of resetting the top 3 bit, and so have this priority inversion. Of course, it's important to consider that if it was mapped to something like BESERF, wouldn't be a problem, but because the uniqueness of this code point that is lower than BESERF, then we don't want this priority inversion.
So thanks, Raffaello, for setting up and actually getting some measurements so we can see what's happening for real. I think it's important we talk about this now, because all the other diffserv classes we've created, all the other PHBs, have actually been PHBs which could live with the best effort service, but were being elevated by the diffserv mechanism. This particular PHB is one that seeks to be worse than best effort. So we don't want other traffic mapped above it by accident or below it by accident. We don't want this inversion. So let's talk about the presentation and let's think about this topic, please. Fred.
So Fred Baker, you've only got 8 options and actually 4 that you can use in your collapsed DSCP. And the reason being that the least significant bit, if set, puts it in a special use class. So it pretty much has to be 0 for any public DSCP. So that leaves you a grand total of 3 values. So if you're going to argue against using 2,
Fred, that's not keep going. Not completely clear. I want to dig a little bit when you get done.
Okay, so
we're talking about pool 1, yes? The pool 1 allocation, which is currently allocated for the standards action.
Yeah,
I'm looking at his slides, in which say 2 might be a bad value.
Yes.
Okay.
Okay.
Also, back here.
4 and 6 may have the
Okay,
same.
so you've got 8 values. They're 0, 1, 2, 3, 4, and so on.
Yes.
Any odd number is a local use code point.
Not quite.
Yes,
No.
absolutely, a local use code point.
It's not. The IANA registry has half of those as local use and half of those as reserved for IANA or local use.
Well, okay, you can't get to them. Bottom line, if I'm going to put it in anything resembling a standards action, I have to go change something in order to get to it.
This is true.
Okay,
But let's
so-
talk about what we need to do, having understood that is.
May I make my comment?
Let me see if I
Carry
can
on.
get the IANA registry up here.
Thank
No,
you.
let's stick with Fred's discussion. We come back to the IANA stuff
Stick
later.
with Fred's discussion. I'll go find the IANA registry.
Fred.
So
go
are we
ahead.
ready to talk?
Just carry on.
Carry on.
Okay. So the value you'd like to wind up with is 0. The value that you're arguing you could wind up with and not like would be 2 or 4 or 6. And I'm not sure I see the real difference in them, from that perspective. I would really like to go back to these people that are doing cost bleaching and tell them that was 25 years ago.
Yeah.
The internet has been different for a really long time. Grow up. This is not your grandfather's internet.
Okay, so we can do this. How many routers were we talking about here? Are we talking about 1 or several ASs or hundreds of ASs?
We are talking about tens of the ASs in terms of measurement.
Okay, we see tens of ASs in 900 measurements. Okay, well.
Tom Jones, University of Aberdeen. Just another argument against 2. SSH is squatting on code points 4 and code points 2. 4 for interactive traffic and 2 for bulk traffic. So bulk copies over SSH. If you use the code point 2, might end up with the LE treatment, which is probably not what they want.
Okay, another point.
Michael Abramson. So the 7 percentage points. Can we go back to the? Okay. Did you observe any when it says modified the DSCP? Was this like all of those? So the 17% includes the 10% of the TOS bleaching, or is this in addition to?
It includes.
Okay. So we have 7% where it's not doing only TOS bleaching. It is all of that. It's setting it to 0, or did people do even other things?
Most of it is to 0.
Okay, but how much of it is not? How much of this is not just setting it to 0?
Well, I guess it's a small percentage, and for example, we can see it from the last slide where we had, we had like the dominant pathologies are Leary bleaching and TOS bleaching in different proportions, and then we have a small number of other code point that we detect at the end that are unrelated, if you want, to the one that we set at the beginning.
Okay, but it's not significant that we should take that into kind of consideration of any time. It's just You saw a few, but that's like outliers.
The main two pathology, I guess, are bleaching and toss bleaching.
And it may be that some of these code points are intentional policies within the diff-serve domain that are admissible. The issue I think that's on the table is the marking of packets that is not probably intentional and is disruptive to the use of this code point. Ones that are disruptive because it's intentional are perfectly okay.
Yes, so I think that to comment to Fred as well, I think a lot of people just, their equipment does something and they don't even know about it. It's probably not even intentional.
Yes, not intentional.
Yeah, so hi, Brian Trammell. I'm reading this eye chart, and I don't actually know what any of the destination points are because
there's a URL.
Okay, I can go get my, well, no. So no, it's pretty clear from even from here that there's a few things that there's basically probably one or two ASs that are actually leaking out. Like we're using for DSCP for actual engineering insider network and it just leaks out, right? And they don't bleach it on the other end or somehow restore it. The question that I came up here to ask was actually, so you said tens of ASs are doing things that might make the 2, 4, and 6 code points not work, so bleaching the top 3, right? How many ASs were in the sample? So we had 9202 unique source destination pairs. Monroe has an access network diversity of like 9 different ASs. So if we're looking at tens of ASs and thousands of ASs, that's different than tens of ASs and hundreds of ASs. So did you look at the size of the AS path? Like, or do you look at the union of all the ASs that you were traversing with this?
Yeah, I mean, with the one that we traversed, and really we consider we discard some sample because if the DSCP was changed quite early along the path, maybe it wouldn't be. It's not longer significant for the one that, for example, if it was bleached, it can't infer anything from the next measurement. So we had many ASs that weren't even reachable from our measurement.
So what is the size of the union of the set of ASs that were traversed by these measurements?
Well, I mean, in total, I think we measure 30 ASs.
There were only 30 ASs on the entire path?
What do you which there I think there were 3 data sets here.
Right.
So there was a large data set from DigitalOcean, and these are edge measurements,
right,
for which there is fewer data points.
Okay, and the magnitude on the so we're really talking about sort of 10 to the negative third, 10 to the negative fourth instances, right? Like, so if we're talking about tens of ASs in the big data set, then it sounds like we can make some phone calls.
We're talking about 10% paths that we saw from DigitalOcean had this feature.
Yeah, but how many different ASs is that? Is the question, and what's the proportion?
Out of how many?
Yeah, so I would suggest going back and having a look at that. I mean, it's pretty clear as input to the discussion that we should start having here that 2, 4, and 6 are bad, and now we get to go fight about 1, 3, 5, and 7, right? But I mean, like, so from a measurement standpoint, it would be really interesting to know what the denominator of the number of AS is, because you said there were like tens of ASs. Like, if it's tens of tens, then we're screwed. If it's tens of all of them, then it's phone calls. So, all right, thanks.
Right, and to the point where Gory and I were sort of quibbling with Fred, it's roughly up on the screen. This is the INA registry, and the important point is that the code points in pool 3 that end in 01 were tagged as maybe utilized for future standards action if necessary. So we did warn people. However, running code wins this one every time.
So now we have the debate, because we have everything on the table. We have... Okay, but... Right, okay, so we need a system. If we're going to publish this as a working group document, we need to know it's going to be better than using CS1. And it's deployable. So we have various things on the table, and how do we balance these out? Do you want to talk, Roland?
Yeah, thanks for these measurements. I think TOS bleach is maybe a misnomer. It should be IP precedence bleach or so it's more precise.
Yeah, it is IP precedence bleach.
Yes. So, yeah, I think we should stop around. So I'm basically, I second Fred's comment. We should stop working around broken implementations, and also I'd like to get this SSH stuff fixed. I mean, why are they using code point 2? It's allocated for standards action, or not yet. That's right. So, and the question is, if we use the other pool, we have to do the same thing, looking out what's currently used in the wild in this DSCP pool, right?
I think maybe we have some data in that pool if we really want to go there, but that's a relatively easy experiment to figure out whether that code point's changed. How operators are using it is an almost impossible experiment, because we don't know how many people put PHPs behind that code point.
Right, although I think Michael's comment is quite relevant here. A lot of what we're probably dealing with here is operators who have equipment that ain't broke, and they're not particularly clear on what all the details are of what it's doing, but traffic seems to flow through it.
Okay, so.
All right. Let's see if we can make up some straw polls. Let me put the mic aside and let's do a little conferring about what we want to ask, as opposed to me asking half a dozen questions and getting it incoherent. Okay, Rafaela, thank you very much. Your group co-chairs are about to earn their exorbitant salaries. Okay, we're going to do this. We're going to do this via show of hands. This is a straw. This is a straw poll, not a final decision. Can I see from a show of hands how many people in the room think? How many people think they understand the issue? Okay, I see about a dozen. How many people think that we have enough information on what's going on to make a decision now? Raise your hands. Okay, the decision we're trying to make here is, okay, so the decision we're going to set up here is, do we stick with DSCP2? Thank you, Bob. Good point. Do we stick with DSCP2 that is currently in the draft, or do we pick another DSCP, which is probably going to be an odd-numbered one? Because in essence, this says the slide you're looking at here that says a 2 is bad will also apply to 4 and 6. So if we accept the argument here that 2 is bad, 4 and 6 go away, and we're going to be looking at odd-numbered DSCP. So the decision that we're looking at is, do we stick with 2, or do we go to one of the odd-numbered DSCPs? And the question I want to ask is, how many people who understand the issue think we have enough information to make the decision now? Please raise your hand if you think we have enough information to make the decision now. I see no hands raised. That is a significant result. Okay, I don't need to ask more questions, because I think we now know what has to happen next.
But we can take more comments. Can we take comments at the mic, Bob, just so that we can make sure everyone hears, because this is where it gets interesting.
That could be a mix of no and not sure.
Indeed.
Even so, there were no hands raised for yes, confidence in making a decision now, and that I think is an important input to what happens next.
Roland.
Given this table, yeah, Roland, bless. Given this table, I think DSCP4 and 6 are even worse than DSCP2 because they have EF and voice admitted, which is kind of bad.
Oh yeah, I think
so the low priority AF is usually ending 3.
But EF, so does EF, which is
which is annoying.
Which is annoying.
So yeah,
so I think I basically, Roland, I think I agree with you, which is that this slide not only demolishes 2, but also demolishes 4. If you believe this slide is a reason not to choose 2, it's also a reason not to choose 4 and 6, and we'll wind up having to deal with the process consequences of using an odd one.
And I guess, just to be fair, on the other hand, if we do decide to use 2, it shows that 2 is better than 4 and 6. Just to be fair.
Tim Chan, or at least as good or bad.
No. I really don't want to see EF and VA mixed in with a lead button.
Yeah, that would be a really interesting combo.
And speaking from our own network, Janet, we don't change any markings as packets go through our network. So I think the problem one is you don't know whether or if people will fix this bleaching and to what extent it actually is out there. The second is, are there any major applications that are using DSCP2 other than SSH bulk data? And the third one is, I'm not quite sure, was there a reason that we picked 2 in the draft and not, say, 5?
Wait.
The last question. Let's see. The last question does have an answer. In essence, it's the IANA registry that was set up once upon a time, many thousands of RFCs ago, designated the even-numbered code points for standards of action and designated the odd ones in 2 experimental local use pools. So that's the answer to your very last question. The other 2, I don't know.
But line 3, it does say, but we might steal it back sometime, I guess. So,
right.
Yeah, so my inclination would be to go with 2, and things will get fixed if it proves problematic.
Yeah,
I would hope.
Next 20 years or so.
Yeah, it's like V4 NAT or something. I don't know.
Brian.
As somebody who came up to raise doubt earlier, and then raised my hand and then didn't raise my hand, I wanted to explain why. But then I had a thought. Actually, I wanted to ask: did you guys do passcode measurements for 1 or 5?
We didn't choose one. We've done passcode measurements for some of these numbers, and I can't tell you that we've actually done 1. We have done some odd and even numbers with
odd
passcode.
and even numbers. But so the interesting ones here are 1 and 5, right? Those are the 2 that
yes
are fraught with minor amounts of process peril and not just straight up illegal.
But just a minute, we have Path Spider, which of course you might be interested in, measurements for DSCP1.
We
shows
do.
That it gets through the network.
Right.
So it's not blocked by people routinely from the core.
Right.
And the pathologies we have would indicate that ISPs who intentionally remark would just remark it the same way as they remark anything else.
Right.
So there's no particular reason why it's bad from a traversal point of view.
That's a low end study, but it would seem to indicate that 1 is better than 2 to me. On the SSH thing, that's the open SSH code base. Can we just send a pull request? It's don't do that.
Yeah. Well, there's a bug report filed for a long time. Oh, do you want to talk, Tom?
Yeah. So there's a pull request fixing those 2. It's 12 years old, and they're probably never going to take it. Just on the 1 and 5, we have edge trace measurements for 1 and 5.
Okay.
The plots are online, which means I can just look this up. But the bleaching behavior looks the same as 2, 4, 6, and 5. They all have the same breakdown.
So it's got basically the same behavior as 2, but without the peril of 2. All right. So I'm going to raise my hand and say I have enough information to make a decision now.
Andrew McGregor. I'll be sitting next to one of the OpenSSH maintainers in about 3 weeks' time, so I'll see if I can convince them to get off those code points.
Okay, thank you. All right, but I do think we have a conclusion that we can't make a decision now. And you may have noticed I carefully did not go through the milestones earlier. Now would be a good time to go have a look have a look at our milestones. So, since we now more or less know what's going on here, we'll do milestones, and then we'll come back to the rest of the agenda. Okay. TCF, I think that's going to be middle. I need to talk to the authors, but it's going to be pushed out a while, probably 2018. This is not apparent. Without trying to criticize them, this is one of many things that they're working on, and probably not overriding priority. Okay. Tim, you're right on cue. I'm inclined to leave that September milestone for DiffServ 802.11 and move with CS1 and deal with what happens to LEPHB later. What would you like to do?
I agree, David. I just was questioning the submission for DiffServ to 802.11 as an informational RFC. It's currently intended status is a proposed standard.
That should be fixed, David. You're wrong.
I'm wrong. All right.
Thank you.
I will fix that. All right. So this is why we put these up here, because bugs sneak in. No idea how that got here. It's a long-standing copy-paste error. Okay. On the other hand, I'm inclined to move LEPHB to December. Let's see if we can get this resolved between now and Singapore. Roland is not screaming at me. That will do.
Okay, for that one, Raflo, do you think we'd be able to take on doing some more measurements? Because it seems like one person was convinced, but maybe we need a bit more data. Yeah.
Yes, I think.
Okay.
I think that what presented was really a part of the measurement, because we were looking also for other things, and we also have our other measurements.
Okay, well, maybe we could get more data for the next meeting, or on the working group mailing list beforehand. And if other people want to join in, speak to Rafalo, because we could perhaps coordinate this and find out really what lies at the bottom of this DSCP rat hole.
Okay. Bob, is October plausible for the ECN and CAP, two ECN and CAP drafts? Okay. And Michael, SCTP, both the 4960 update and the NAT support end of year. Are you going to, particular NAT support is the one I think that needs your bandwidth. Okay. And part of the reason this slide exists is when I look at our set of milestones, I discovered we had 5 September drafts due in September. I knew that wasn't going to happen. Okay, now we need milestones for the remaining drafts. Bob, September 2018 is a swag for L4S. Do you have a better swag? I mean, that's basically a year out. We'll go with that for now.
Early is good.
Yes. We like early. The ADs like us. The AD and the other ADs like and the other ADs like our ADs when that happens.
Just to explain, Bob, what I mean about that. When we did the presentations, we're going to say that essentially those drafts are finished, barring changes in TCPM to the TCP Prague stuff. So they're just sort of sitting in holding pattern, waiting for that.
There is also the possibility, if you want, to freeze something like the architecture and do an early working group last call, but not actually publish it, because we might want to update it, but just to get everybody's consensus on it. So
that would be a good
procedure.
idea. Yes. Yeah.
Okay. UDP options. Making a guess. I guessed after the spring meeting next year. That gives us 2 meeting cycles. I mean, I don't think the spec is going to change much. I think it's mostly an understanding of implementability and effect on implementations that don't support. All right. Options. April 2018. Is Vincent here? Vincent Roca? Vincent, is June next year plausible for the FEC drafts? Okay, good enough. Excellent. We're happy to share the credit if you get them done more quickly. We'll talk more on Thursday. Right. And the rest of this is all agenda stuff. Okay. Let's see, where were we?
Bob next.
Who's Bob next? Yeah, 3-3.
David, while I'm talking on the first half, the second slides I sent you, I just realized there was a priority inversion in my in one of the slides, so I've sent you a corrected set of slides for the second.
Okay.
The shim one.
Okay, you'll
get any questions.
You'll get to see the actually what I'll probably do is just unplug this while I go find an email. Let's go through this set of slides and then I'll go find your others.
Okay. So this one, there's the co-authors. Hanging around for ages. Next slide. Just to recap what this one is, it's a BCP intended. It's guidelines for protocol designers of lower layer protocols, and there has actually been 2 going on since this was started, which have both used it. It's not straightforward because it's cross-layer, and it's also cross-organization. So we've done liaisons on this, and in the process of writing this, the normative text in it being a BCP, we decided to pull it out into a another standards track document so that it could update other standards track drafts, which I'm going to come on to. Right. Things that have been going on recently. This draft has been stable for quite a while. It's but stuff is happening. One very important thing going on in 3GPP is to a proposal from Ericsson, in fact, reference number 1 down there, to try and make ECN visible at the RLC layer in the 3GPP stack, because the IP header is compressed by the time you get there. And this is for architectures where the PDCP layer is distributed from the RLC layer. So that would require this draft. It was proposed in their June meeting, and there were counter proposals to because it's sort of they've already got this technology called RAN-based codec adaptation that's just for one application. It's basically for voice over LTE, and so there was some people saying no, we don't want to do ECN because we've got this. Others saying well, let's do both, and others saying not, and all the rest of it. And when you look at the minutes, everyone's quite confused about what the differences are between them and what their scope is and all the rest of it. So in the end, the decision was deferred until August, but I would encourage any 3GPP delegates to understand the implications of this decision, mainly because the proposal from Ericsson was primarily so that they could support L4S with very low latency without having to jump back in the stack to another node to report ECN. So yeah.
This also came up over lunch at the 5G and IETF meeting. Is Georg here? No.
I have news because the 5G people will come talk in our liaison slot on Thursday.
Okay.
So you might want to just raise this.
Let's bring this back up. Although Stuart Cheshire put this on everybody's radar screen over lunch. So that's a start.
Yeah, that's because I put it on his.
Now, don't show everyone how the sausage is made.
Right. The other recent activity is Donald, who's sitting here right in front of me, and myself have got ECN supporting trill through, and I think this has to hold. It's gone. I think it has working group last call completed. Yeah, yeah. But it's got a normative reference to ECN NCAP guidelines, so I assume that still goes. Write-up goes, but then it just has to hold until.
And as you saw from the milestones we just bashed, the hope is to have ECN NCAP guidelines and the 6040 shim draft submitted for RFC publication before Singapore.
Right. So it might be quite nice if they all go to the ISG together, because then they will have read them all.
We just
and sort of they all understand them all together. Okay, next. So I've got some edits queued for the next revision, but I'm holding them until the updates. The edits are all in the section that summarizes the bit we split out. And until I've been to Interia on Thursday to talk about that, I don't want to put that summary in stone, because Interia might say differently. But otherwise stable for some time, and I've now got an incorrect slide because you've just changed the milestone.
I'm sorry, what have I just done?
Change the milestone. It's okay.
That's okay. Look,
yeah. Sorry. Right, so I guess, did you manage to get the corrected slides?
No, I'm going to have to go. I don't.
Don't worry. I can just explain where the point at which my brain flipped.
Okay.
Yeah, apologies to the people on the list when I couldn't decode binary into decimal as well earlier on.
Right. Actually, if you got
that's a pointer. Yes.
Then I can point to where my brain flipped.
Your brain flipped. Okay, go for it.
So this is okay. While we're doing this, second set of blue sheets. They were here a moment ago.
Who hasn't seen the blue sheets? Can you put your hand up? Random pattern. I'll go looking.
And who's got the other blue sheet? I'll go. Oh, there it is. Okay, so we got two blue sheet boards. Okay, go ahead. All right, Bob, carry on.
Okay, so this was the one I just mentioned that was split out of the other one to be a proposed standard, so it could update other proposed standards. Can I move it on then? No. All right.
No, sorry.
And this is the diagram that's split. You can just see it. That one's correct, but upside down. No, that one's correct and not upside down, and then these all go upside down and they're incorrect, and it's sort of
all right.
Too little sleep. You know?
We know where.
I know when you put the outer on top, but I thought, well, I better put the outer on bottom. You know?
It's IETF week.
Yeah.
Okay, but the point here being that you have an L2, you'll have an L2 header riding on a shim, riding on the outer IP.
Yeah. Okay. Now hang on, just let me tell you what that slide's about. Yeah. So the scope was of RFC 6040 was IP and IP, and it never said anything that IP has to be directly on IP, but some people assume it did and some people assume it didn't. So this update is to make it clear that it includes a shim, and that shim might be extended with a layer 2 header as well before you get to the other IP header. And it could even apply where you don't know whether the inner is IP or not. But if it's something inside a layer 2, it's probably going to be IP. And then if you don't know what it is, you really shouldn't be putting anything in the ECN field on the outer except 0, right? So there's text in the draft to make this all clear. I won't go through the text. You can read the draft. Carry on. Next. So I then went and had a look at how many specs are covered by this, because we covered the IP and IP with about 3 or 4, but then I discovered that the Interia has been quite busy. And also maybe
some of these are actually routing.
Yeah. So what these columns mean, ended up deciding let's not deal with anything here except standards track stuff or widely deployed stuff. So the first column if there's a cross in there, there's no further information in the other columns, because we're going to ignore all that. When I say first column, I mean third column, of course. You should all know when I say first, I mean third. Then the AOK column is saying that it refers to either RFC 6040 on tunneling or on a previous compatible RFC like RFC 3168. And I'll come back to some of the exceptions like the SFC one in a minute. I'll just explain the table first. Then the two NOK, not OK columns, they're two different sorts of not OK. One, there's text in this draft now that makes them OK, if there's a tick there. And the final one is they're not OK, but they're not IETF documents either. Or at least they're RFCs that document other people's protocols if they are, so we don't have change control over them.
And what's the tick that's not a tick against NVGRE? I want to know.
Yeah, it just says it depends on the one above.
Oh,
yeah.
See above, as in when you fix that, you get this one for free.
Yeah.
Okay.
Right. Okay, and the NA, they're not applicable in SFC, sorry, which is service function chaining. Allegedly, they haven't produced a new encapsulation. They've just produced a load of vagueness about. Sorry, did I say that out loud? They've just sort of produced architecture and stuff, and there's no actual encapsulation yet. Right.
Look for draft. I think with let's see, it used to be NSH was the name of the thing that was going to be.
No, but that doesn't actually say what the encapsulation is. It just says how it might be, and it doesn't yet say how it would be if there's already an encapsulation and things like that. Yeah. So then the ones in the column where it says the text in this draft updates them are now on the next slide, all about them. So there's two L2TP ones for the very old V2, which is still around for PPTP, point-to-point tunneling protocol, and then L2TP version 3, which is often used for Ethernet and other layer 2 stuff, tunneling. And then there's GRE and there's Teredo. And these are all significantly different, actually.
No kidding.
The L2TP one, it's that all the controller management is automated. There's a protocol to do that. The GRE one, as far as I know, is only ever manually configured.
Wasn't there some VPN products using GRE?
Well, this is sort of what I want to know, because I've been asking. I mean, if there are, they must be automatically configured. But I can't find any protocol that does it.
Okay.
And I can't find anyone who will sort of admit to looking at the interior mailing list long enough to answer my question.
So is the question to TSVWG? Does anyone know how GRE is automated in another protocol? Does anybody know? Oh, that got some people to look at me. Carry on talking, Bob.
I've got a 5-minute heads up in interior where I want to ask this question.
Yeah, we'll start that. I mean, a lot of GRE when it was originally done was statically configured. I have seen a number of auto tunneling protocols proposed, but I can't recall IETF adopting any of them.
Yeah.
Aha.
Okay.
So I actually would like to answer that question. I can't say yes or no, but I can say that if Banana, which had a BOF yesterday, is chartered and they decide that GRE is a tunneling mechanism that they might want to use for non-TCP traffic for doing multipath bonding, then they will find or define a configuration, provisioning, discovery, whatever. We couldn't come up with a word that not like half the room hated, protocol, which would kind of qualify as automated GRE tunnel setup.
So I think I heard an if and a might do in that construct, Brian.
Can I also say that if they find it doesn't have that, can they not invent one? Because there's plenty of other choices.
Right. Yeah. I'm actually if if that charters, then I took a picture of your slide that I'm going to show at the first working group meeting. It's like, choose one.
Yeah.
Please, and also, or choose 2, or choose 6, but preferably in the AOK column, so this doesn't impact that work. Thanks.
And so I'm still just going through the why these things are significantly different. Then, of course, Teredo is generally end system to end system, and so it's not, network configuration and thing doesn't apply. And I see Christian there, so maybe I'll get some answers out of Christian as well. So I'll talk to him later. So going one level deeper on each one, the L2TP one, I've proposed, and in consultation with Carlos and Ignacio, a new attribute value pair so that the two ends can negotiate ECN, and that's all written up, and the IANA registry bit is written up, and all how it's meant to work. For GRE, it's just manual configuration as far as I know, so there's not much to write other than comply with 6040 if you're the person manually configuring it. And then Teredo, it's sort of difficult because the spec didn't mention ECN, and there's a lot of Teredo out there. So if we start having ECN working underneath Teredo, I don't know, and I'm sure Christian can't remember what the code looks like without thinking about it, but whether it copies the ECN header or zeros it is important, because if it copies it, then it will be black holing ECN if there's any ECN enabled on your path. So we need to check that. And sorry, question.
Jake Holland, I don't think AMT was on that list.
Okay, that was a question I meant to ask. Have I missed anything? AMT.
I also don't see IPsec tunnel mode.
No, yeah. This is not. IP and IP is not on this list because they were already covered by.
Oh, okay, good.
Right, these are ones with shims.
Right.
So I don't even know what AMT is. What's AMT?
7450 automatic multicast tunneling.
Oh, no, I did find that. Now, why did I reject that? I can't remember, but okay. I will.
Yeah. We probably should have a talk about that one, because there was a big discussion in the group about control plane and how that interacted with it. So we should have something in the document that refers to it.
Right.
Yeah, Christian Ritema. The question about Teredo is that there are two parts to answer your question. There's is it conceptually hard to have support for ECN in Teredo? And the answer is no, it is not. There is no particular reason why not. And the second question is, if we update the RFC to specify that support, will application also be updated?
Exactly.
And that is a much harder case, because as far as I know, some of the implementation is in hardware.
Yeah.
So
this is all about the legacy problem.
Yeah. And so it's unclear that I mean, it might be, but I mean it will be updated typically for new products.
Yeah.
And
and then there's Moredo as well and things like that.
And Microsoft is not the only one implementing Teredo.
Yeah, it's Dave Dolson. If I understand this correctly, this could be a cap WAP is IP with Ethernet, or actually it's Wi-Fi, I guess, header then IP. And you're talking about skipping ahead to find the IP header so that you can mark it or appropriately when you remove it from the tunnel.
There's two aspects. One is, and I've got slides on what the problem is next. But one is that if there is an IP outer and an IP inner somewhere, then if you're going to not have a zero in the outer ECN, you should first check that the other end of the tunnel will be able to process it.
I guess, okay.
Right. And so it's a question of coordination between the two ends of the tunnel. And if you don't know, then you should zero it. That's the first That's the main problem, particularly with legacy.
Mhm.
Yeah. Okay, you can go. Stay on this one. No, stay on this one a bit longer. No, I think we're done on that. Yep. Other than to thank all the people it acknowledges in the various working groups. I've been beating up on a number of people for the last couple of months. Right. So this is exactly what Dave Dawson was asking. So ECN is different to any other field in the IP header when you're tunneling. And so to give an example, diffserv gets copied down, but then when it comes to the decapsulation, it's just thrown away. The outer is just thrown away. But with ECN, the capability goes down, and then any changes to it have to be propagated back up again, right? And so it has to check when it's doing the encapsulation whether the decap would support that combination of the inner and the outer before it gets forwarded. And if not, it should zero it. So the problem is, if it doesn't check, then marks it ECT because it's come in as ECT. So like in the Teredo case, then you've got ECN capable on the path. If you go through, say, a FQ coddle upstream on your Teredo, it might mark it, but then those markings just get dropped on the floor and you get all hell break loose, as you see there. And so what that will mean is it will toggle between tail drop and then ECN, and it will give you really bad performance. So that's the problem. Next. The next problem on top of that problem is that in RFC 6040, I wrote it and we reviewed it as a specification of what compliant implementations would have to do. But what we didn't do is write it from the point of view of what an implementation that doesn't comply with it should do. And in this one case, even if it doesn't comply with it, it has to do something. Right? It's like it's a requirement for all things that use the internet protocol, all tunnel endpoints, whether or not they comply with RFC 6040. And so in this update to 6040, I've added some text, because all you can do there is just say the operator should configure it to be safe, right? And I've actually, rather than should, I've said, if possible, the operator must, right?
We're going to wordsmith that for you.
Well, I don't know if Spencer's happy with that. Yeah, but let's talk about those words.
Because what that implies is that the implementation gives them the possibility of configuring it. And that's why there's the if possible. If it's not configurable, they can't do it. If it's configurable, they must. But you're telling an operator must is sort of, you know. Yeah.
This is one of the few cases in which we do use must and get kind of insistent about it, because losing congestion indications from the network is a must not.
Yeah, exactly. So and then in the Teredo case, the operator is the end user, you know. So
actually, not quite.
Okay, that's true. Yeah,
because the operator is. I mean, the Teredo setup is really automated.
Yes. Yeah.
And Teredo effectively has an explicit setup with a system of probes and all that. So I have not done the work, and I don't want to presume about it, but it's possible to specify something like, if your initial setup probes carry the bit end-to-end, then you notice that the other guy is capable,
right?
And you use it. Whilst if they do not, then you deduce that it is not capable and you zero the flag.
Yeah.
So I mean, things like that are possible. It's not that
but
hard.
It's more, you know, like in versions of Windows 95 and things like that. What's happening? You know?
No, but you will be in a way in which basically Windows 95 will always send the bit to 0 anyhow. And it's not Windows 95, actually it's Windows 7.
That's true.
But
yeah, that's true.
But they will send a bit to 0,
yep.
and they will not acknowledge it when you send a probe. And that way, the other system will notice that the system at the other end of the table tunnel cannot do it. So you can automatize it. It's possible.
Yeah. Okay. Yeah. Right. So yeah, that's the end of that slide. So status and next steps. There's been 4 revisions of this draft. A lot of work's gone into this draft to try and meet that deadline of what was September. And I think we can still meet it. Hopefully Interior will close off some of the remaining issues. I've got a session with Praveen next week because I thought he was going to be here, but he's not. So to deal with Teredo. So I think we're in good shape.
Are you actually presenting at the Interior meeting?
Yes, unfortunately, I put in a request very early to do so, and it got lost. So they've only given me 5 minutes.
But 5 minutes to do heads up when I mean, it's been around many of the Interior groups, so just as long as people get heads up, because I think this is important cross-area document.
Yeah.
It's good to get eyes on it.
Thanks. Okay. So we've got rest of the time is L4S. So how does the L4S team want to use this? I have no slides at the moment. I would have to go get it if you sent me email with slides.
Let's go find slides.
Let's go find slides. Okay. All right.
Okay, I'll try and remember what the first slide is. Probably a title slide.
With your name?
Yeah.
Okay, so
L4S architecture.
So there's 3 drafts that have been adopted by the working group.
Yep.
And we are looking for people to actively engage with this process. And the whole purpose of bringing these drafts to an IETF working group is that they become owned by the working group, which means people get a chance to change them, people get a chance to implement them or experiment with them or see how it fits their architecture. So if these drafts are going to mature as we hope, Bob's going to need help from the working group just to get more feedback on them as they go forward. Hope that was okay, Bob.
That was
our intention.
That was. And just as you have a sort of state of the working group slide, one of my slides is going to be state of the L4S across all areas, because it's not just these 3 drafts and not so it's sort of a coordination problem within a coordination problem, if you like. And that's where a lot of other people are putting in effort and things like that. So
we've got the slide here.
Yeah. Getting close.
Okay.
Right. On the L4S architecture, I think I can remember how the slides go. It's essentially written, could be reviewed, but we want to go into a holding pattern, as I said, and work more on the transport layer now, and check that we can produce a safe transport that meets the TCP Prague requirements. We've already got one that's unsafe and meets them, so we're in pretty good shape as far as having an existence proof.
And we have
excellent.
Slides.
Right. Okay, there's the co-authors. This is the architecture one first. A recap. The L4S architecture is 3 parts. The AQM with the dual queues to protect L4S from classic and but to still share out the capacity, so you get very low latency, which is the whole point. Very low queuing delay, I should say. There's a classifier, which I'm going to talk about in the next draft talk, which is ECT1. That's been preliminarily decided. And then there's the congestion control on the host. Next. So this is the holding pattern slide I was just talking about. In very small text there, it actually says 1 minute. In that loop goes around, so I'm going to get an email every minute saying, "Have you finished yet?"
From the pilot.
Yeah. So in effect, we're nearly done on the dual queue one. Koen's going to talk about that after me, and then that will go into a holding pattern, I think, as well, because there's some assumptions in there that depend on, just in case we have to change TCP Prague type requirements, it's best to put them all in a holding pattern. And we gave a talk in ICCRG about some of the more ambitious things we're trying to do with TCP Prague, because we're researchers, but then there's the basic stuff, which is just implementing it, putting together accurate ECN, ECN++, DCTCP, and all the bits and pieces to make it safe, and testing that all out. And that's the sort of thing I'm talking about to finish, and then everything can go through. We don't have to do all the performance improvements because it's already 10 to 100 times better latency than anything else. So we don't have to make it even better to do that, to get all the drafts to go through. So yeah, 500 microseconds delay, queuing delay, versus the best is about 5 milliseconds, and that requires fair queuing, or flow queuing. So yeah, we don't want to stay in this holding pattern because you'll always be updating your transport protocol, and we need to have a cutoff point. Next. So this is the iTest. This is what I said about the status of all the other parts. As you can see, all the red bits mean work being done, updated bits and pieces. Pretty cool, actually. In the IETF specs bullet, which, if you can see that, there's only now one of those specs is not adopted in the various working groups. They're all adopted. The only one that isn't is the quick one, ECN in quick. And what else should I highlight out on here? Oh yeah, the 3GPP bit I'm going to talk about. Oh no, I just talked about, didn't I? And that's coming up for discussion in August. Oh, and finally, we're still trying to get the paper we wrote about it, the research paper we wrote about it, accepted, so that all the measurement results, we did millions of scenarios of measurements. But this one got rejected by SIGCOM on the basis it's not novel because they'd heard about it in the IETF. So
we can have them 2 seconds of silence as everybody sighs when they did the same, but carry on.
Even though we'd made it very clear which contributions there were in the paper that were different from...
Doesn't work that way.
Yeah. So we're going for journal submission now, okay. And you'll hopefully have that public. Right. So moving on to the identifier. I'll go straight into this. We were having a discussion about, this is written into the identifier draft, but maybe I ought to call it out a bit more. Yes. We've talked about ECN being the identifier, but if you like, that's the default identifier and the ever-present identifier for the end-to-end service. But it's possible, we don't want to prejudge how this gets deployed by different operators, and they may want to make it initially something that they do only in their own network, or only for certain like business customers, or for their VPN customers or whatever. We don't know. So it's possible that this will be the ECN identifier and another, optionally. And so that may be the address of one end, it may be a VLAN ID, it may be a diff-serv code point, maybe a local one or a global one, it may be the bearer ID in a mobile network, so and we're about to put the hooks in the code to use the Linux classifier architecture so that people can just add another classifier as well as the ECN one. Really just want a discussion about this because, well, the implications for diff-serv as well, but also just the business implications, because if you provide this flexibility, it will probably get used, and that could delay this being an end-to-end service for many years. And whereas if you don't provide it, I suspect people will abuse it and do it in a bad way. The idea of doing this is that at least when you take out the optional one, it becomes an end-to-end service eventually.
David Black speaking from the floor. So I expect Bob and I have a Socratic dialogue in our future on the subject of glass half full, glass half empty on this one. I'm one of the people poking Bob on this for a couple of reasons. One is that at the very least, DSCP and some of the other classifiers that Bob mentions help an enormous amount when you think about incremental deployment, and I think that's going to be an important aspect to bring out. And I think beyond that, in general, the notion that this is a selectable add-on to a service is a good one.
Yeah, I just wanted to pick up on the point about incremental deployment. I think the more identifiers you add together, the less incremental deployment you'll get. ECN currently goes through pretty well most places, although we've got some more recent measurements on mobile networks that we're going to talk about at the next IETF. But when you start saying ECN and diffserv, you reduce the Venn diagram of where both will get through to just the middle of it.
Yeah, and this is also a perspective discussion, because I'm thinking in terms of this being an enhanced service on individual networks, and there you're going to want network-specific classifiers, and then we see how the world evolves and the extent to which we can get this to become end to end. And
I think a better word rather than incremental deployment is deployment motivations, business motivations for deploying it. May require.
We'll figure out the words, but I just did want to make it clear that Bob and I talked offline. There's probably some wording changes needed in the draft to emphasize that second classifier is optional and quite useful and important as I'll use your words, deployment motivation.
Andrew McGregor. If you don't specify that or put it in the Linux code, someone else will.
Yeah.
Because I cannot see how I can do the testing required to put together a deployment of this without it.
Yes.
So
thank you.
It'll just be there.
Thank you.
Okay. So next. So we had a bit of a discussion in TCPM about another piece of this jigsaw, which is now called ECN++. It's the file name there, TCPM generalized ECN, which is about making sure you've got ECN on all the TCP types of TCP packet, not just the data packets. And the point was made there, as it has been before, that this at least now makes everything consistent, so you don't have all these exceptions in your load balancers and things where these load balancers another thing that is broken in, as Fred was saying, they're still working on the internet our grandfathers built. They're still using the 8-bit TOS byte. So when the ECN field changes, they load balance to another place, right? So at least having all the packets in one flow have the same ECN field can be useful. But I just wanted to point out here that, of course, if they're classifying on the last bit, or
just
on the second from last bit, then there's ECT and CE.
Yeah. This is really something that people have to fix.
Yeah.
I mean, we saw the other DSCP mess, but this is something you have to fix, because as soon as your router happily marks ECT 1 or 0 to CE, it blows.
Yeah.
So this is just brokenness. Big headlines. Please don't use the whole byte called the TOS byte in olden times. Use only the DSCP field for load balancing.
Because what we've been finding, and we haven't yet found any correlation, is because there was so much diffserv bleaching that it was 100%, so we couldn't correlate with something that was 100%. But the ECN field bleaching was, I suspect, a bug from people who thought it was the TOS byte rather than trying to bleach the ECN field, but I don't know.
David Olson. It occurs to me it might be nice to have tools to debug this. So I think someone's working on like the traceroute version of reporting this.
We use tracebox. Yeah.
So do we actually like change traceroute so that everybody's traceroute gets like this big flashy warning about the ECN bleaching? I just wonder, there might be an idea there too.
Ooh, that sounds fun.
Yeah.
That could be clever.
Yeah, there's a
Getting
tool called,
changes by making
there's a tool
shout.
called Tracebox that does that.
Subversive.
It comes up in red if there's a change from what you expect. Yeah.
Andrew.
Andrew McGregor. There's also the species of hilarity that occurs when routers pull the whole of this byte into their ECMP entropy, and then you get ECN marks causing drastic reordering.
Okay.
Yeah, don't do that.
ECMPP people also do not do that. That's also written, but please just don't do it. Yeah, ECMP causes the same problem if you take the byte.
The thing being that I'm aware of at least 2 different router vendors who have multiple ways of configuring their DSCP, their DiffServ implementations, the right way and the wrong way, both in the same device. And for a long while, the default in the documentation was the wrong way.
And going back to L2TP, this is a problem there in that a lot of the tunnels allow DiffServ configuration to set the DiffServ code point to a certain thing, or to copy the DiffServ code point from inner to outer, and most of them treat it as a byte.
Okay. We done here?
Done.
All right.
10 minutes remaining.
Come on. I got 10, 15? 15, I think. Whatever.
Hello.
5 minute talk.
A short overview for the dual queue drafts. Next slide. So further improvements that were done was we submitted the adopted draft. We added the overload handling pseudocode for it. Also, the pi heuristics, which were removed from the dual pi square, have been assessed and discussed now on the mailing list. So we were also working on this open source release in Linux. So we have simplified the pi square parameters. So we would say we would do some cleanup. So the pi square configuration parameters, they were simplified because there was quite some interdependencies between parameters. Like if you wanted to change the updates time, you had to also accordingly change the alpha and beta parameters. Similar for K with the dual, with the coupling factor between the 2 queues. So this is being removed. And well, there are the extra classifiers we are working on, and we hope we can soon upstream it. That's more or less about the status. Next slide. I also want to repeat a kind of concern that we raised in the ICCRG meeting. So it's a warning, or at least a concern of a clash that we see, looking more and experimenting more on with BBR mainly. So there is a sender-only evolution having also solving on a tail drop based or buffer bloated environment where you have big queues without AQMs. There is also a solution in evolution which is okay, because we can't have AQMs everywhere immediately. But on the other hand, all the AQM work that has been done is actually clashing with what is currently in the Linux kernel as BBR, and which seems to be deployed already extensively. In the next slide. So if you look at BBR on a tail drop queue, you see that there is, so here you can see 4 flows running, and you see the dynamic flows. I don't know if you remember, but there are multiple sizes, and that's the completion time. So you see it's a reasonable good completion time. There is also, without an AQM, a limited queue of around 20 milliseconds in this case, which is on a 100 megabit link, and 20 milliseconds round trip time. But the problem, of course, if you introduce an AQM in this situation, which is on the next slide, and we have a pi AQM, which has a target of 15 milliseconds, it will increase the drop probability, but BBR ignores drop for quite extensive amounts. So it will induce a lot of drop probability, which has an immediate effect on the completion times for the short flows, even for BBR themselves. So, which is of course not good. So it makes the situation with an AQM worse than without an AQM, which is not a good evolution, let's say. It's not what we want, and it's not what is the intention of the work done in the AQM working group. So in the next slide, the question is, will BBR as is and this evolution force operators to disable AQMs in the future together with ECN? So that's a little bit a concern, I think. And in the next slide, the question is, well, we proposed actually a solution in ICCRG, which probably we will further experiment with, and also I hope the BBR people. But the question is also in which working group should we handle these kind of clashes?
Interesting, but BBR isn't in any working group. So this is a topic we just have to discuss. ICCRG seems the right place to discuss it at the moment since it is being presented there. But heads up, we should be aware of what's going on in the internet for real.
Yep. Okay. Any other questions?
What do you plan to do next? Always a good question.
Yeah, so if there are review comments for the dual Q drafts, we're happy to receive them. And if you have experience with it, please test it and try it. We like to hear comments from you and experience.
Thank you.
Yep.
Thank you. So we have another slice of TSVWG on Thursday. It's in session 2 on Thursday afternoon. Please come along, and that will also handle our liaisons discussion, the SCTP drafts, and the FEC frame. So please come along to that also. Otherwise, have a great day. Thank you ever so much for coming.
Go.
So we'll be on the vote.
If we walk to the
Otherwise, just think they have to early and later though. Otherwise, if scared, it doesn't make any sense. Also, the social data might be two places if people didn't get them. Yeah.